In this episode, we make acronyms feel less like a wall of random letters and more like a set of familiar signposts you can recognize quickly and confidently under exam pressure. For a brand new learner, acronyms can be frustrating because they arrive faster than the concepts behind them, and they often sound similar even when they mean very different things. On an exam, that confusion can slow you down, and timing matters. But the bigger problem is that misunderstanding an acronym can send your reasoning in the wrong direction from the very first sentence of a question. The goal here is not to memorize an endless alphabet soup, but to build instant recognition for high-yield acronyms by tying each one to a plain language meaning and to the kind of decision it usually shows up with. When you can hear an acronym and immediately think, this relates to identity, or this relates to access control, or this relates to assurance evidence, you move through questions more smoothly. We will also focus on how acronyms cluster together, because many exam items use several in one scenario, and your job is to keep them straight without losing the main idea. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A good way to approach acronyms is to treat them as labels for recurring roles, processes, and technical building blocks, rather than as isolated trivia. Many acronyms that appear in security engineering are simply shorthand for something you would understand easily if it were written out, like a job role, a type of document, or a class of control. For example, Chief Information Security Officer, CISO, is a role that represents executive-level responsibility for information security strategy and program leadership, which often comes up when questions involve authority, accountability, or governance decisions. Security Operations Center, SOC, usually refers to the team and function that monitors, detects, and responds to security events, which often comes up when questions involve logging, monitoring, incident handling, or operational assurance. Service Level Agreement, SLA, is a formal commitment about performance or availability expectations, which often influences engineering trade-offs and risk acceptance. When you attach each acronym to a category like role, operations, or governance, you reduce confusion because your brain knows what kind of object it is before you even process the details. That categorization is the foundation for instant recognition. Identity and access management acronyms are especially high yield because they appear across many scenarios and often sit at the center of trust decisions. Multi-factor authentication, MFA, is a method of verifying identity using more than one type of evidence, which reduces the risk that stolen credentials alone can grant access. Role-based access control, RBAC, describes a model where permissions are assigned to roles and users are assigned to roles, which is useful for consistency, least privilege, and manageable administration. Access Control List, ACL, is a list that explicitly states who or what can access a resource and in what way, which can be applied at many layers and often appears in boundary control discussions. Public Key Infrastructure, PKI, refers to the systems and processes that support digital certificates and public key cryptography for identity, trust, and secure communication. When you see these acronyms, the exam is often testing how you manage trust in identities and how you control what identities can do, not just whether you know what the letters stand for. If you recognize the category, you are already halfway to recognizing what kind of decision the question is aiming at. Network and boundary acronyms also show up frequently because security engineering relies on managing interfaces and controlling exposure. Domain Name System, DNS, is the system that maps human-friendly names to network addresses, and it often appears in questions about availability, redirection, spoofing, and trust in name resolution. Internet Protocol, IP, is the foundational addressing and routing system for networks, and it often appears in questions where you must reason about communication paths and where controls can be placed. Virtual Private Network, VPN, is a method of creating a protected communication path over an untrusted network, which often ties into remote access, segmentation, and boundary security. Demilitarized Zone, DMZ, is a network segment that sits between trusted internal networks and untrusted external networks, commonly used to host services that must be reachable while limiting exposure to internal systems. Intrusion Detection System, IDS, and Intrusion Prevention System, IPS, are related but different, with IDS focused on detecting suspicious activity and IPS able to take action to block or prevent certain activity. Recognizing these acronyms quickly helps you focus on the real issue, where the trust boundary is, what is crossing it, and what controls or monitoring are appropriate at that boundary. Risk, governance, and compliance acronyms can feel abstract to beginners, but they are high yield because they shape how security decisions get justified and documented. Risk Management Framework, or MF, is a structured approach to managing risk through a life cycle of categorizing, selecting controls, implementing, assessing, authorizing, and monitoring, and it often appears when questions involve assurance evidence and accountability. Authority to Operate, ATO, is a formal decision that a system is acceptable to use from a risk perspective, usually after assessment, and it often appears when questions involve governance gates and acceptance criteria. Plan of Action and Milestones, POA and M, is a document that tracks known issues, planned remediations, and timelines, and it often appears when the scenario involves managing risk that cannot be fixed immediately. Statement of Work, SOW, is a procurement document that defines what work will be done and under what conditions, and it matters because engineering and security requirements must be expressed clearly in such documents. Memorandum of Understanding, MOU, is a formal agreement between parties, often relevant when systems integrate across organizational boundaries and trust must be defined contractually. These acronyms are signals that the question may be about governance structure, risk acceptance, or the way security gets integrated into organizational decisions, not just technical controls. Assurance and engineering process acronyms often appear when questions test how security is built into the system lifecycle and how confidence is produced. Software Development Lifecycle, SDLC, refers to the phases and practices of building and maintaining software, and it is important because security requirements, design, verification, and change management must be integrated throughout. Quality Assurance, QA, is the discipline of ensuring that processes and outputs meet defined standards, which relates to both product reliability and evidence of disciplined engineering. Configuration Management, CM, is the control of system changes, baselines, and versions, which is critical because uncontrolled change can destroy security posture and break assurance. Security Technical Implementation Guide, STIG, is a set of configuration recommendations and requirements, often used in regulated environments to standardize secure configurations. Continuous Monitoring, CONMON, is an approach to ongoing observation of security posture and control effectiveness, which supports sustained assurance rather than one-time confidence. When you see these acronyms, expect questions that connect requirements to design and design to evidence, because that is where security engineering becomes measurable rather than hypothetical. Cryptography-related acronyms are also common, and they often appear in scenarios about confidentiality, integrity, authentication, and non-repudiation. Advanced Encryption Standard, AES, is a widely used symmetric encryption algorithm, and it usually appears when the question involves protecting data at rest or in transit in a practical, performance-aware way. Secure Hash Algorithm, SHA, refers to hash functions used for integrity checks, signatures, and safe storage of sensitive representations, and it often appears when the question involves tamper detection or password handling concepts. Transport Layer Security, TLS, is a protocol used to protect data in transit by providing encryption and integrity between endpoints, and it often shows up in boundary and communication scenarios. Diffie-Hellman, DH, is a key exchange method, and it matters because it supports secure session establishment without sharing secrets directly. When these appear, the exam is often testing correct use and purpose, like whether you can tell encryption from hashing or authentication from confidentiality, rather than asking you to compute anything. In a beginner-friendly mindset, focus on what problem each cryptographic concept solves and what kind of mistake would undermine it. Another cluster of acronyms that matters for security engineering is the set related to logging, analysis, and operational visibility. Security Information and Event Management, SIEM, is a platform approach for collecting, correlating, and analyzing security-relevant logs and events, often supporting detection and response. Endpoint Detection and Response, EDR, refers to capabilities focused on endpoints, like laptops and servers, for detecting suspicious activity and supporting investigation. Data Loss Prevention, DLP, is a set of controls designed to prevent sensitive data from leaving authorized boundaries in unauthorized ways. User and Entity Behavior Analytics, UEBA, is an analytics approach that looks for unusual behavior patterns, often used to detect compromised accounts or insider risk signals. The presence of these acronyms often indicates that the scenario is about visibility and detection, and the decision may involve where to collect signals, how to interpret them, and how to produce actionable evidence. For ISSEP-style thinking, remember that operational tools and signals are part of assurance because they help you maintain confidence after deployment. The exam often cares that you understand the relationship between monitoring and sustained security posture. A beginner-friendly way to avoid acronym overload is to listen for what kind of story the scenario is telling, because acronyms often appear as characters in that story. If the story is about who can decide and who is accountable, acronyms like CISO, ATO, and POA and M are likely to be central, and you should think governance and risk acceptance. If the story is about who can access what, acronyms like MFA, BAC, ACL, and PKI are likely to be central, and you should think identity and trust. If the story is about what crosses a boundary and how it is protected, acronyms like DMZ, VPN, TLS, IDS, and IPS often appear, and you should think interfaces and control placement. If the story is about proving security over time, acronyms like SDLC, CM, QA, and CONMON are signals, and you should think evidence and traceability. This story approach keeps you from treating acronyms as random and instead uses context to reinforce meaning. Over time, context-driven repetition creates the instant recognition you want. It is also important to address a common misconception. Recognizing an acronym is not the same thing as knowing how to apply the concept. Many learners can expand an acronym but cannot explain why it matters, which leads to weak answers on decision-focused questions. For example, you might know what our BAC stands for, but the exam may be asking whether our BAC is appropriate for a fast-changing environment or whether another model would better support least privilege. You might recognize SIEM, but the question might be about what kind of evidence you need for assurance or about how to avoid being overwhelmed by noise. In other words, acronym recognition is a speed skill, but application is the scoring skill. The best way to merge them is to attach each acronym to one sentence of purpose, like this exists to control access through roles, or this exists to produce centralized visibility and correlation. If you can say that purpose sentence quickly, you are far more likely to choose correctly when a scenario uses the acronym as a clue. Because you are learning through audio, you can practice acronym mastery with a simple mental exercise that does not require writing anything down. When you hear an acronym, pause mentally and name its category, like identity, boundary, assurance, governance, or operations. Then say a purpose sentence in your mind. And finally, imagine one mistake that would happen if someone used it incorrectly. For MFA, the mistake might be assuming it eliminates phishing when it mainly reduces risk from stolen passwords. For DMZ, the mistake might be assuming it makes a public service safe even if the service is misconfigured or vulnerable. For CM, the mistake might be allowing urgent changes without proper control until the system becomes untraceable and insecure. This exercise builds practical understanding because it binds the acronym to meaning and to failure modes, which is how engineers learn. It also improves recall because failure stories stick in memory better than definitions alone. As we close, the big takeaway is that acronyms are not a separate subject you learn once and then forget. They are a language layer that sits on top of security engineering decisions across every domain. High-yield acronym recognition helps you move quickly through question text, but the real advantage comes from attaching each acronym to a category and a purpose so you know what kind of decision it usually affects. When you see identity acronyms, think trust in people and permissions. When you see boundary acronyms, think interfaces and exposure. When you see governance acronyms, think authority and risk acceptance. When you see assurance acronyms, think evidence and traceability. And when you see operations acronyms, think visibility and response. If you build these mental associations, you will stop feeling like acronyms are trying to trip you up, and instead you will use them as signposts that guide your reasoning. That is how you master exam acronyms without turning your brain into a dictionary. And it is how you make instant recognition support, rather than replace, sound security engineering thinking.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.